Assalamu alaikum. Hope you are doing fine. We know a cell is made of electrodes and electrolytes. They provide resistance called as internal resistance. In this video, we are going to learn how to determine the internal resistance of a cell using potentiometer. I have connected the potentiometer to measure the internal resistance of a cell or battery. For that, this end of potentiometer is connected to the positive terminal of battery or power supply. Then negative terminal of battery or power supply is connected to this end of potentiometer wire through a key and rheostat. This forms a primary circuit. Then this end of potentiometer wire is connected to positive terminal of cell or battery whose internal resistance is to be determined. Then the negative terminal of this cell or battery is connected to a jockey through high resistance and galvanometer. Apart from this, a plug key and resistance box are connected across this cell or battery. This forms secondary circuit of the potentiometer. Now I will turn on the circuit to check whether the connection made is correct or not. For that, I press the jockey at one end of potentiometer wire. The deflection is observed in this direction. Now I press the jockey at this end of potentiometer wire. Now the deflection gets reversed. This ensures that the connection made is absolutely correct. Now the plug key is removed. This means I have not included the resistance box in the secondary circuit. Now we will find out balancing length for that. I press the jockey at the center of first segment. The deflection is in one side in the galvanometer. Now I move to the next segment. The deflection is observed in the same side. Now I go to the third segment. I repeat this till the galvanometer shows deflection in the reverse direction. Now the deflection has got reversed. This means that the balancing length lies between these two segments. Now I move the jockey this way. At this point, the galvanometer reads 0. This is known as null deflection point. This the length of potentiometer wire up to this point gives balancing length L1. Then I include this resistance box in the secondary circuit. I add 10 ohm resistance. Now we'll find out the balancing length by repeating the same method. I press these segments till the deflection in the galvanometer gets reversed. The deflection has got reversed at this point. Now I move the jockey in this direction. I go to the previous segment. At this point, the galvanometer shows zero deflection. The length of the potentiometer wire up to this point gives a balancing length L2. Here I have drawn the circuit diagram to measure the internal resistance of a cell using potentiometer. If you look at this diagram, you may find that end C of potentiometer wire is connected to positive terminal of battery or power supply, and the negative terminal of battery or power supply is connected to end D of a potentiometer wire through a key K1. This forms a primary circuit of a potentiometer. And end C of potentiometer wire is connected to positive terminal of cell Xi, whose internal resistance is to be determined. Then the negative terminal of cell Xi is connected to jockey through galvanometer and high resistance. This forms a secondary circuit. Apart from this, here we have a resistance box and a key K2 connected across the cell Xi. Now, by keeping K2 open, I move the jockey along the potentiometer wire CD to find a balancing point. At one point, at point J, the galvanometer shows null deflection, zero deflection. So we take that point as balancing point, and the length of potentiometer wire between C and J is taken as balancing length L1. From the principle of potentiometer, it is found that the EMF of cell is directly proportional to balancing length L1. Then I close the key K2 and I include some resistance. I select some resistance in resistance box. So for example, the resistance included here is 10 ohm. In such case, again I move the jockey on the potentiometer wire. At one point, the galvanometer shows null deflection. We call that point as balancing point, and the length of the potentiometer wire is referred as balancing length between C and point G. Now, this balancing length is taken as L2. Then this L2 is found to be proportional to V. Here V is the potential difference between C and J when the resistance box is, when the resistance is included in the secondary circuit, and is found to be directly proportional to balancing length L2. Now, the current flowing through the potentiometer wire is taken as I. And it's equal to the ratio of EMF and the total resistance. Here the total resistance is capital R plus small r. Here small r is the internal resistance of this cell. So this equation is obtained from Ohm's law. We know Ohm's law is V equals to IR. From this, I can be obtained by taking R this side. V upon R. Similarly here, in the place of R we have R plus R, which is the total resistance. Here R is said to be gets added with the internal resistance. So the total resistance is R plus R and the EMF is Xi. When we divide these two, we get the current from Ohm's law. Now I go ahead, I'll find out the value of V. From Ohm's law, V can be obtained if I multiply I with the resistance R. From Ohm's law, V equals to I R. Here, the value of I is known to us, I R. So from this, V equals to, what is the value of I? Is Xi upon R plus small r. Then it is multiplied with the resistance included by us. It is capital R. This is the value of V. And from this expression, V is found to be directly proportional to L2. Right? V is directly proportional to L2. And the value of V is nothing but epsilon Xi upon R plus small r into capital R is directly proportional to L2. Now, we have two expressions for balancing length. This L1 and this one, another expression. I take this as equation 1 and this one is taken as equation 2. Now, I take equation 1. What is that? Xi is directly proportional to L1. Now, if I remove this proportionality, I have to include a constant along with equal to sign. This is what I do. I rewrite this one as Xi equals to constant into L1. I take this equation as equation number 3. Then I take equation number 2. Equation number 2 is Xi upon R plus R into capital R is directly proportional to L2. This is written as Xi upon R plus R into capital R. So I remove proportionality. So I put equal to sign along with constant. Then L2. I take this one as equation number 4. Now I divide these two equations. I divide equation 3 and 4. If I do so, what do I obtain? I get this. Xi upon Xi divided by R plus small r into R. Then equals to this side. I take this part. Constant multiplied with L1 divided by constant this part multiplied with L2. Now the same terms get cancelled here. I cancel these two. And what do I obtain? Is nothing but this. Xi upon Xi R and multiply these two, divided by R plus small r. This is what I obtain. Then it's equal to L1 upon L2. Now, I do a slight modification to this. So I keep this term present in numerator as such. I bring denominator to numerator. If I do so, it will get inverted. So I will take the reciprocal. When this term comes to numerator, it gets inverted. R plus R divided by xi into R equals to L1 upon L2. Here the similar terms it cancel. So, and what do we obtain is nothing but this. R plus small r divided by capital R is equal to L1 upon L2. Now, I expand this expression. How I do so? Look at here. Expand it this way. First I take R and divide by the term present in denominator. That is R divided by capital R plus I take this term and divide it by the term present in denominator. So this, it is equal to L1 upon L2. Now if you look at this two get cancelled, it becomes 1. Let's divide these two, get 1. So this equation can be written as 1 plus R upon capital R is equal to L1 upon L2. This can be written as, now my aim is to get the value of small r, that is nothing but internal resistance. So I take a 1 to that side. Here it is getting added up with this term. When it is taken to that side, it will subtract. Now R upon capital R remains here. This side L1 divided by L2 and plus 1 will become minus 1. Minus 1. Box this. Then the next step, what I will do, see, I'll keep small r here, this way, and this term, small capital R, which is in the denominator, is taken to right hand side. So it will multiply. So R into L1 upon L2 minus 1. This is the final expression we obtained. This is the internal resistance of the given cell for a particular value of R. If we change the resistance in the resistance box, then you will get a different R. This shows that internal resistance of a given cell is not a constant. It varies with the load or the external resistance. So it is found that when R increases, internal resistance also increases. So in simple words, we can say that R is that is internal resistance is directly proportional to external resistance, because here this term is a constant. So we can say R is directly proportional to capital R. It means when R value increases, small r value will increase. I hope this video is useful. If you have any kind of doubt related to the topic, can you put your questions in the comment section? Thanks for watching.